Hello everyone, this is Katish here. In this video, I will be going through the AQA Combined Science Chemistry Paper 1 Foundation Tier from 2025. This paper is 1 hour 15 minutes long and it's out of 70 marks and it has 7 questions. Now questions 6 and 7 are higher tier questions, which means they appear as question 1 and 2 in the higher tier paper. So in this video, I will be going through questions 1 through 5 because these are foundation tier questions, and questions 6 and 7 I will do them separately as a separate video, and I will link it to the playlist for this paper. Let's have a look at question number 1, which is on the topic of atomic structure. This question is about atoms and ions. The model of the atom has changed over time. In an early model, scientists thought that the model was a tiny sphere that could not be divided. Figure 1 represents this early model of the atom. Now this model is what we call the solid sphere model. And this was proposed by someone called John Dalton. So, solid model proposed by John Dalton. The discovery of a subatomic particle led to the change in the model in figure 1, which was the first subatomic particle to be discovered. That would be the electron. This was the first particle to be discovered, then the proton was discovered, and then the neutron was discovered last. In a later model of the atom, most of the mass was concentrated in the center of the atom. What is the name of the center of the atom? That would be the nucleus. Atoms contain 3 types of subatomic particle. Draw one line from each subatomic particle to the relative charge of the particle. Electrons have a negative charge of -1. Neutrons have no charge or 0. And protons have a +1 charge, +1. What is meant by the atomic number of an atom? That would be the number of protons only. Now the number of neutrons only, we don't refer to anything. We don't give a specific name, but the number of neutrons plus the number of protons, that would be the atomic mass. Table 1 shows information about 2 isotopes of an element. Isotope A and B each have a mass of 10 and 11 with a different percentage abundance. Calculate the relative atomic mass of the element. Use the equation. So we need to multiply the mass number by the percentage of isotope A and then add it to the mass multiplied by the percentage of isotope B. So let's say AR equals 10 times 19.7 plus 11 times 80.3, divide that by 100. That should give me 10.803. Now they want the answer in 1 decimal place. So that would be 10.8. And oxygen Atom has 8 electrons. Complete figure 2 to show the electronic structure of an oxygen atom. Now remember, an atom has shells. These lines that are shown here are the shells. So in the first shell, it can have a maximum of 2 electrons. Second shell can have 8, and then 8 again. And then let's say we have 8 again. So because it has 8 electrons, oxygen will have 2 electrons in the first shell and the rest of the electrons, 6 electrons in the second shell. So that's 2 electrons in the first shell, and then 1, 2, 3, 4, 5, 6. Figure 3 shows represents two models of sodium chloride. Now sodium chloride is an ionic compound because it's made up of a metal and a non-metal. So an ionic compound because that's a metal, that's a non-metal. So you have model A representing sodium chloride and model B representing sodium chloride again. This one is actually showing the ions with a positive and the negative charge. Model B is also showing the ions, but it's a 3D structure. So what are two advantages of model B compared to model A? Well, model B shows the 3D arrangement of the ions. Model B shows the charges of the ions. Both of them actually show charges. Model B shows the electronic structure. It doesn't. Model B shows the relative size of the ions. Yes, you can clearly see the positive ion is smaller, or the sodium ion is smaller than the chlorine ion. That brings us to the end of question number 1. Let's have a look at question number 2. Lithium carbon. Question number 2 is on the topic of bonding structure and the properties of matter. Lithium, carbon, nitrogen, fluorine, and neon are elements in the same row of the periodic table. What is the chemical symbol for lithium? Use the periodic table. That will be Li. Lithium has metallic bonding because lithium is a metal. Which electrons are involved in metallic bonding? That will be delocalized electrons, but it has to be from the outer shell. So delocalized electrons from the outer shell. Lithium reacts with fluorine to produce lithium fluoride. Again, it's an ionic compound because lithium is a metal and fluorine is a non-metal. Draw one line from each substance to the particle diagram that represents the substance. So solid lithium is going to be this. Fluorine gas. Now fluorine gas is F2. So it has to be the same element. So that will be that. Lithium fluoride solid is going to be this. Right? If lithium fluoride, if it was a gas, this is actually a gas. So let's say lithium fluoride gas, it will be the third box. Table 2 shows the electrical conductivity of 3 substances. So you have substance C, D, and E. Electrical conductivity when poor, when solid, C and D are poor, E is good. Electrical conductivity when liquid, poor, good, and good. So, okay. Lithium fluoride is an ionic compound. Which substance is lithium fluoride? Now, ionic compounds will conduct electricity during, if it's mixed with water, but in solid state it won't. So it has to be D. Now the main reason for it is because the ions cannot move when they are in a solid state, so they can't conduct electricity, but in liquid states the ions can move. Carbon can exist in different forms. Figure 4 represents one form of carbon. Now the diagram that is shown is that for diamond. What is the name of the form of carbon in figure 4? That would be diamond. Carbon and fluorine form a compound with the formula CF4. Calculate the relative formula mass of CF4. So carbon has a mass of 12, fluorine is 19. Now that is four fluorine atoms. So relative atomic mass is 12 plus 19 times 4. That would give you 88. Figure 5 represents a molecule of nitrogen. We have nitrogen. We have 1, 2, 3 electrons from this nitrogen with a cross being shared, and 3 electrons from this second nitrogen being shared. Okay. What is the total number of shared electrons in the covalent bond? That would be 6. We are just simply counting these electrons which are in the middle. So that would be 6. Lithium and nitrogen form a compound with the formula Li3N. Complete the sentence, choose the answer. What is the name of the compound with the formula Li3N? Is lithium nitride. Neon does not react with other elements to form compounds. Why is neon unreactive? Now neon is in group 8 or group 0, which means it is the 10th element in the periodic table, so which means it has 8 electrons, and it's in group 8 or 0, so it has 2 and then 8 electrons in the second shell, which means neon has a stable arrangement of electrons. Let me draw that, just give you an idea. So neon has 2 shells. First shell has 2, second shell has 8. Done. Question number 3 is on the topic of quantitative chemistry. A student investigated the reaction of magnesium with oxygen. Now this looks like a required practical to do with the law of conservation of mass. Figure 6 shows the apparatus. So you have magnesium inside a crucible which is being heated up and a balance. This is the method used. Measure the mass of an empty crucible. Add 0.1 gram of magnesium to the crucible, or heat the crucible and contents for 5 minutes. Allow to cool and measure the mass of the crucible and contents. Repeat steps 1 to 4 using different masses of magnesium. Complete the word equation for the reaction. Magnesium plus oxygen will give you magnesium oxide. Complete the sentence. When magnesium reacts with oxygen, magnesium is oxidized, meaning oxygen is being added. Table 3 shows the measurements for one of the experiments. The empty crucible is 20.25 grams. Crucible magnesium before heating is 20.55. Crucible contents after heating is 20.75. Calculate the mass of the magnesium in the crucible before heating. So if I take away 20.55 minus 20.25, that will give me 0.3 grams or 0.30, 0.30 grams. Why does the reaction result in an increase in the mass of the contents of the crucible? A solid reacts with a gas to produce a solid. That would be the answer, because the solid is the magnesium and the gas is the oxygen to produce magnesium oxide. The student determined the mass of the contents of the crucible after heating each mass of magnesium. So you can see most of the points are in a straight line except for this one, which looks like it's an error, which we call an anomaly. Draw a ring around the anomaly in figure 7. So we've already done that. The student did the experiment using 0.60 grams of magnesium 4 times. Table 4 shows the results. We have the mass of the contents of the crucible after heating in grams, and there's 4 results: 0.96, 0.93, 0.92, 0.95. They're all within range, so they're close to each other, so there's no anomaly. Calculate the mean. So we add all 4 values: 0.96 plus 0.93 plus 0.92 plus 0.95, add all of them up and then divide it by 4, which will give you 0.94 grams. The student used a Bunsen burner instead of a water bath to heat the crucible. Why did the student use a Bunsen burner? A Bunsen burner heats up the crucible more slowly. That depends on the setting of the flame. The water bath is not hot enough. That would be the best case. If you want to heat it, you can't use a water bath. The crucible will dissolve in a water bath. No, the crucible is porcelain, so it won't. A different student did the investigation. The student heated the crucible for 1 minute instead of for 5 minutes. The student obtained different results. Suggest one reason why the student obtained different results. Well, if you're reacting it for 1 minute instead of 5 minutes, that means maybe some of the magnesium did not react. So some of the, I'm going to write the symbol for magnesium instead of writing the word magnesium, did not react. That brings us to the end of question number 3. Let's have a look at question number 4, which is on the topic of chemical changes. This question is about metals. Complete the sentence. Most metals are found on Earth as compounds. Usually as oxides. Iron is extracted from iron oxide by reduction with carbon. Why is iron reacted or extracted by reduction with carbon? Iron is less reactive than carbon. Iron has the same reactivity, definitely not the second one. Iron is more reactive. If iron is more reactive than carbon, it's not going to displace it. So iron is less reactive than carbon is the correct answer. Aluminium is extracted by the electrolysis of aluminium oxide. Figure 8 shows the apparatus used to extract aluminium. So you have positive electrodes, molten mixture of aluminium oxide and cryolite, the negative electrode, molten aluminium at the bottom. The mixture of aluminium oxide and cryolite has a lower melting point than aluminium oxide alone. Why is the melting point lowered? Well, to reduce the amount of energy used for the process. If it had a higher melting point, you will need to use more electricity, which costs more money. After some time, the positive electrodes need to be replaced. Now, the positive electrodes are basically graphite rods. Which means they're made up of carbon. So during this process, you're actually breaking down aluminium oxide, which is Al2O3. Now this, once you separate the oxygen from the aluminium, that oxygen will react with the carbon to form carbon dioxide, which means that graphite rod is slowly going to burn away. So could you say the electrodes dissolve in the mixture? Not necessarily. The electrodes melt. Now the electrodes react with aluminium. The electrodes react with oxygen gas is better. Aluminium can be mixed with other metals to form alloys. How does the hardness of an alloy of aluminium compare with the hardness of pure aluminium? Now, pure aluminium is actually soft and ductile. So the alloy is harder than the pure metal. That would be the correct answer. Aluminium can form an alloy with silver. Figure 9 shows how the melting point of the alloy changes with the percentage of silver in the night mixture. So as you increase the percentage of silver to about, let's say 75, about 70, at about 70, the melting point goes down and then it actually shoots up. Okay? Describe how the melting point of the alloy changes as the percentage of silver in the mixture increases. So at the start, as the percentage increases, the melting point decreases. So the melting point of the alloy decreases as percentage of silver increases up to 70%. Right? Or you could also say, if using the value from the melting point, it would be somewhere, well, there, that is going to be 500 and about 530 degrees. But I'm going to leave it as a percentage. Then the melting point increases. That brings us to the end of question number 4. Let's have a look at question number 5. This question is about acids, which is on the topic of chemical changes. Okay. A student investigated the volume of an alkali needed to react completely with 25 centimeter cube of an acid. So it's a neutralization reaction. We are reacting an alkali with an acid. Figure 10 shows the apparatus used, universal indicator paper inside the acid. That would actually turn red because of the acid. dropping pipette containing the alkali. As you drop it, the acid is going to be neutralized little by the alkali. Eventually, when it's completely neutralized, it should turn green. And then, if you add more alkali, it will turn towards blue and purple. This is the method used. Add 25 centimeter cube of the acid to the beaker. Add a piece of universal indicator paper to the acid. Add the alkali drop by drop to the acid until the universal indicator paper changes color to green. So that's when it's completely neutralized. Record the number of drops of alkali used added. The student did not give an accurate volume of alkali needed to react completely with the acid. Now they're adding it drop by drop. So unless you measure the volume for each they're actually counting the number of drops. So suggest 2 improvements to the method. Instead of adding it drop by drop, maybe they can measure the volume of the alkali. So measure the volume of the alkali added. Instead of using a dropping pipette, you could add it using a burette, which basically is that long tube, glass tube, when you're adding titration, which looks like this and which has a tap, and you can actually make the measurements. So that's your burette. That would actually be more accurate. Another improvement is you could repeat and calculate a mean. Mean value for the number of drops. They haven't mentioned about stirring the mixture. So it is important that you stir the mixture. Stir the mixture while adding the alkali. And instead of a universal indicator paper, it's better to actually use universal indicator solution. Use solution, or better still, use a pH probe. It will tell you when the pH is exactly 7, because judging by the color can be a bit tricky. So that's 5 different points that I've given you. Any of 2 of those will be fine. What is the pH of the solution when the universal indicator paper turns green? That would be 7 because it's neutral. What name is given to the reaction between acid and alkali? That is neutralization. Which ion do all acids contain? That will be the hydrogen. Name the acid that reacts with sodium hydroxide to produce sodium nitrate. So it has to be nitric acid. Figure 11 shows a reaction profile for the reaction between an acid and an alkali. So this looks like it's an exothermic reaction. Why am I saying it's an exothermic reaction? This is the reactants energy is more than the products. So this is the reactants, this is your products. Right. So that's part of the question. What do labels A and B represent? So actually they are just only asking for part of it. Let me label all of the rest of it. So the reactants are here, products are here. Now this from the tip to there is the activation energy. A is the energy change during the reaction. B has to be the progress of the reaction. So we can label. So A is the overall energy change. B is the progress of reaction. Acids also react with the insoluble solid substances to produce salt solutions. When making a salt solution, excess solid is added to the acid. Draw the apparatus used to separate the excess solid from the salt solution by filtration. So you need to draw a plastic funnel with the filter, paper, and the rest of the equipment. The apparatus should collect the excess solid and the salt solution. So you will need the filter paper only for 2 marks. So you will need a conical flask. Let's draw the conical flask first. And you will need a plastic funnel or a glass funnel is fine. Make it shorter. Draw this. And the filter paper, use a different color paper. And you're going to have the solid that is stuck there. So let's label this conical flask, plastic funnel, filter paper. That's your excess solid, and that'll be your salt solution. They're not asking you to label the diagram, but if you label it, that means that you definitely know what you're talking about. So solid X reacts with hydrochloric acid to produce zinc chloride and hydrogen gas. Name solid X. Now if you're going to react with hydrochloric acid and you get zinc chloride, then the solid has to be the zinc, which is the metal. Zinc. That brings us to the end of question number 5. Now remember, question number 6 is the higher tier question, which is on chemical changes. I will do the video for this question separately and link it to the playlist. And question 7 is on the topic of energy changes again, for exothermic and endothermic reaction, and there's your 6-mark question for this paper. Thanks for watching the video. Hopefully you find this useful. If you did find it useful, hit the like and subscribe for more content. Thanks for watching. This is Ketish here again. Bye for now.